Okay. So today in section 6.1, we're going to solve those systems, okay, and we're going to do that by graphing, and then we're going to be able to analyze special systems. Luke, can you see them? If you can't, you can come sit right there if you need to. You can see how it goes. If not, you can just get up and move, okay? All right, so a system of linear equations are two or more linear equations, okay? So a system for those. Now the solution is going to be an ordered pair that's true in all those equations. Consistent is a system of equations with at least one solution. Inconsistent would be a system of equations with no solutions. Okay, so if they're dependent, they're going to have infinitely many solutions. If they're independent, they're going to have exactly one solution. Anybody have a guess as to what the two graphs are going to look like if they have infinitely many solutions? Anybody have a guess? Can you make a conjecture what do you think they're going to look like if they have infinitely many? They're going to look like one line. You got it. Good job. All right, so let's go ahead and try example 1. Solve the system of equations by graphing. So everything that we learned last chapter about how to graph quickly, you're going to use this chapter. Okay? Remember that we looked at things, well, first of all, when we solve two equations, what we're looking for is the point where they intersect. So find point where they intersect. Okay, that's what, when you're asking something, like when you're graphing, you're going to find the point where they cross, okay, where they intersect, and that's going to be our answer. Just one simple answer. Okay, now let's remember how to graph quickly. If it's y equals mx plus b form, very quickly, you always graph this point first. Okay, that's your number 1. Then from that point, you rise over run, right? That's your second point. Okay, remember what we did? Okay, so let's graph our first one. Y equals 2x plus 4. So your first one is 4 on your y-axis. From there, you do rise over run. Now, I don't see 2 in the form of rise over run. So, Richie, what is 2 over?
2 over 1.
Yeah, very good. That's really 2 over 1. So from that point, it says rise up 2, run over 1. It's positive, and you're going to connect it. Now, I saw some of you guys doing some pretty neat things. Instead of just connecting it at random, you just went from that point 2 over 1, and then you went from this one, you went down 2 over 1, down 2 over 1. So you kind of had So since you didn't have a straight edge, you just kind of had a bunch of points to kind of connect, which is awesome. Okay, you just kept doing that rise over run. Okay, now let's do our second one. Doug, where's my first point going to go on this one?
2 on
Good.
the y-axis.
2 on the y-axis. Perfect explanation. And then, Doug, where do I go?
And then you go up 1 and over 1.
Good, because there's not a number here with x, so that means it's automatically 1. Now again, I could connect those two, but if I don't have a straight edge with me, I'm just going to go down 1 over 1, down 1 over 1, down 1 over 1, and I'm going to connect my dots right now. Okay, so the question is, where do they cross? Okay, well, I actually have it right here. So my coordinate for that, Trevor, is -2, 0. Very good. Okay, so when you're finding a solution with graphing, you're going to literally, okay, find where they cross at that exact coordinate, and that's going to be your answer. All right, let's go to example 2. Solve the system by graphing. Sarah Ann, where's my point for the first one? -3. And where do I go from there, Sarah Ann? Good, go rise over run. Now there's not a number there, so it's automatically 1. So go down 1 over 1. So go down 1 over 1, down. All right, Reese, tell me how to graph the second one.
Graph of 5 on the y-axis.
Good, and from there?
0 down 1 over 1.
All right, Ella, what's my solution to these? Do they ever cross? No. Nope, so no solution. They're not going to intersect, right? Now, without graphing these, I could have actually looked at this and known that they are parallel. And we did this the last time in the last chapter. When you looked at the slopes, when both slopes are the same, you knew the lines were going to be parallel. Very good. So same slopes are parallel lines. So they never intersect. Right? You could have looked at that just at the number in front of x when it's in y equals mx plus b form and know that they'd never intersect.
But if they have the same line intersect, wouldn't it be dependent?
Oh, it doesn't ask me that in this one. Right? It doesn't ask me to be. Infinitely many solutions is the question you'd answer to have to be on top of each other. All right. Oh, that's it for notes. Do you have another sheet in your packet?
Nope.
Not good. All right, let's get out. Let's just flip it over on the back side then. All right, this one's going to be solved by graphing also. Y equals 3x minus 3. And my second one's going to be 3y equals 9x minus 9. Hannah, what's different about this equation than this equation? Good, the y isn't by itself. So let's divide everything by 3. So now I get y equals 3x minus 3. Did you need something, Ms. Busby?
Yeah, the other one.
Okay.
I'll come back.
All right, so let's graph this. You ready, Miss Pearson? Graph the first one for me. Tell me what to do.
3x
Nope.
negative 3y.
What do you mean negative 3y?
You put the point on negative 3.
Okay. On the y-axis, you mean? And now what?
Rise over 1, so you would go positive 3x.
Nope. Nope.
I know how to graph that.
Okay. Kyle, help her out. So she put the negative 3 on the y-axis. Now tell us where to go from there.
We wanna rise 3 over 1.
Very good. We want to rise up 3. We want to run over 1 because our slope is 3 over 1. All right, Jordan, help me with this one. Graph the second equation for me. Where am I going to put my first dot at?
Negative 3.
Good? Okay. Where am I going to go from there?
Up 3 over 1.
Up 3 over 1. Wow. So did we notice that when we started? Yeah, they were exactly the same. Now Luke answered this for us. When they're exactly the same line, when exactly the same line, there are infinitely many solutions. Right? They're the same line. So we find our answers by where they cross at, but the lines are laying on top of each other. Okay, so I want you guys to notice that. When you have exactly the same equations, you only have to graph it once. There's going to be infinitely many solutions. Okay, they'll be the same exact line. All right, example 4. And I'll just put it up here for you guys. Okay, I'll just put it up here and we'll read it together and then we'll work it out. All right, so example 4. One satellite radio service charges $10 per month, plus an activation fee of $20. A second service charges $11 per month, plus an activation fee of $10. In what month will the cost of the service be the same? Okay, so you ready? If it's 10 per month, that's going to be the times part, right? And then what do I do about this plus an activation fee of 20? What do you guys do? Yeah, plus 20, right? So my first one I have y equals 10x plus 20. Let's go to our second place. Our second one says a second service charges $11 per month plus an activation fee of $15. So Jared, from our first equation, copy for our second place. What should that one look like? Y equals, how much are they going to charge each month? Nope, your second place. The first one did $10, that's why we did 10x. Yep, so 11x. And then what are we going to put plus at the end of ours? Yep. So y equals 11x plus 15. Okay, so there's our two equations. So let's go ahead and graph this. Now how come when we're graphing this, I don't need a plus graph? How come I only need a big L graph? Yeah, you're not going to have a negative amount, right? You're already, if you just even start it, you're going to have a $20 and a $15. So this could kind of get a little hard. So let me show you how to do it on your calculator. You ready? Get your calculators for me. Open a new document and get to the graph page. Actually, you guys, let me finish these notes. All right. So right here, if it intersects at one place, it's going to have how many solutions? 1. When they're on top of each other, how many are they going to have? Infinitely many. When they're parallel lines, how many? No solutions. Very good. They don't ever intersect, so they can't.